Assalamu alaikum, dear viewers. Mm, In this video, we are going to discuss the difference between mathematics and statistics by using a very interesting example. The relationship between the study hours of a student and his marks. So, let's begin. Say the study hours of a student is denoted by x, and the marks he obtains is denoted by y. So the equation, the mathematical equation, let's see how mathematics and statistics deal with this scenario. In mathematics, we get a simple equation. Uh, for example, maybe y equal to 20 plus 3.33x, where y is marks obtained by the student and x is study hours. So this y equal to 20 plus 3.33x, this means that if a student doesn't study at all, he will still get 20 marks. That is, when x equal to 0, we get y equal to 20. That means if the study hours is 0, he will still get 20 marks. And depending on his study hour, if he studies more, say 1 hour, 2 hour, say up to 24 hours without sleeping, in that case his marks will be, let's see this, his marks will be this is our programming, and by this we are very easily showing the marks and the estimation and graphs, which we'll see later. And let's see this. The study hours could be 1, 2, 3, 4, 5, and up to 24. And depending on the study hours, we saw here, the marks will be like this: 23, 26.6, 29.99, and 99.92. We made the equation such that the total number, since we said that total number is 100, so we made the equation so that the total number does not exist 100. Okay, so this is how mathematics deals with the scenario. If a student, the more a student studies, the more marks he or she gets, using this simple equation: y equal to 20 plus 3.33x. uh, uh, if we know how many hours student studies, we can exactly tell how many marks he will get. We can exactly tell it. There will be, unless we make an error in our estimation, in our calculation, we'll exactly know how much marks the student will get. But is this situation real? In real life, can we exactly tell by knowing a student's study hours? um, we know that how much mark a student will get depends on many other things. Maybe it is study hour, maybe whether he pays attention to classes, maybe whether he attends classes regularly, and many other things, maybe hundreds of thousands of reasons. But say, even if we know all the reasons behind working behind the marks of a student, will we ever know how much marks he will get? Will we exactly know this? The answer is no. We can never exactly tell or predict how many marks a student will get. We can only guess. Okay, that's where the difference between statistics and mathematics. Mathematics deals the matter a bit differently. Say the marks, we only have the marks of the students and their study hours. Uh, Say the marks are, uh, say we have these marks, the 21.98. We have made this. Basically, the first point is, in statistics, since we do not exactly know how, depending on the study hours of the student, how much marks he will get. We do not exactly know this. So there is always, maybe it was in mathematics, according to this simple equation. According to this simple equation, maybe it if we study, let's see here, if he studies 1 hour, his marks will be 23.33, but his marks could vary. This says that his marks is 21.98, could be 21.9. How we attain this mark is, we introduce an error term. This is called error term, which can be positive or negative. That means the marks the student gets could be above or below the mark predicted, not predicted, estimated by mathematics, estimated by this simple equation. The actual mark could be smaller or greater than this mark. Okay, so that's what we did here. We made up an equation. The equation is 20 plus 2 times x plus an error, which could be positive or negative, this error. This is what this equation tells us, 20 plus 2x. We made up this equation so again, so that the total number does not exist 100, since we said y marks of 10 out of 100. So this is this equation. By writing this equation, we introduced an error term in the marks. So the marks could be, in this case the marks is lower, and in this case also this is lower, and always this is lower because of the equation, because of choosing the number 2. Okay, so what basically statistics does this is, when we have some data, maybe one variable depends on another variable. In this case, study hours affects marks of a student. So study hour is independent variable, and marks student obtains is dependent variable. So what statistics does is make a model from this data and predicts what the future result of another outcome would be. Yeah, say a student studies 2.5 hours. What will be his expected result? Prediction. This is what statistics does. It doesn't predict like mathematics simply. So simple equation. If you predict by this equation, you will be wronger always. But if you use statistical tools to predict, say we have these marks, study hours and marks, since say we have this initial data from somewhere. So based on this data, we have to predict. Now we have to predict how much marks a some students with with different study hours will get. So basically the math works like this. We have to, using graph, we can see it is this graph. Let make myself tiny. So if we draw this curve, this says that it is what mathematics is. If you, depending on study hours, the marks will increase. And now if we introduce error term, this will be the scenario. The marks will vary. It sometimes it will increase, sometimes it is decrease. It will decrease. So we cannot, by seeing the fluctuation, by seeing the fluctuation, we can tell that this cannot be predicted or guessed. Just cannot be predicted or guessed exactly. Now, what statistics does is make a model. Is to make a model to predict this. Say we have marks and study hours, then we have to predict what the expected result of some student studying or some given study hours, which marks he will get. So the model is, in this case we have made a model by using simple linear regression, one of the simplest and the first model for a beginner. For a beginner who is using statistical learning statistical model, this is called simple linear regression. And using this regression, we have found some values. Let's run this, and the outcome of the model. In this case, we have got some outcomes which says that intercept is 19.719 and study hours 2.008. This means that even if a student doesn't study at all, his marks will be 19.719. Remember one thing: these marks we have got from this data, marks 2, that is this column of data, and this data. So statistics predicts that even if a student doesn't study at all, his expected mark will be 19.719 or 72 approximately. And there is another important outcome. Another important outcome is which calls that coefficient of study. It is called coefficient of regression. It is 2.008. This means that if a student studies 1 more hour, his marks will increase by 2.008. For example, say if a student studying 3 hours, a student got 40 marks. So by increasing study hour, increasing his study hour by 1 hour, if he studies now 3 hours, his marks will be 40 plus 2.008. That means 42.008. So this is how statistics predicts, and in using this graph, we can make the prediction. If we run this, we'll see the prediction. This graph is our prediction graph. So this was our initial. This fluctuating line was our initial random marks, in which there are some error terms, because of which we could not exactly predict number of predict marks of the student. Now this line predicts that even predicts that fluctuating line. So that is how statistics deals with data. It gets some random data from which it makes model and makes future prediction. It doesn't say like mathematics. In mathematics says that okay, if a student studies student X hours, his marks will be 20 plus 3.33x. That's it. But that doesn't work in real life. The real life is so much more complicated. It has randomness. It can randomly increase or decrease, could be greater or smaller. So statistics deals with that. It makes a model. It finds the pattern of that fluctuation, of that randomness, and make predictions accordingly. So that's all. That's the key difference between mathematics and statistics. And also, we'll discuss in a future video that that is how actually science works. And without statistics, science is a big zero. And if you think closely, that this is how actually science works. Science makes model of the universe to and makes theories and predicts using those theories. If the theories work correctly, they can make good predictions. We can call it a good theory. Good theory. Because of this practice, many theories were vanished, were cancelled, or you may call were nullified, like Ptolemy's theory and even Newton's theory. Actually, no theory is ever correct. That all theories, all scientific theories are models, like this linear regression model, in which we predicted marks obtained by a student depending on his or her study hours. So that's how science works, and we'll elaborate on this later, inshallah. That's it for today.